We're working on calculus. Let's look at another program. Let's look at the accumulator function. For a long time, I only had this first page of the accumulator function so that the teachers could use it as an illustration. And then I finally added the problems, and I think the problems are very useful for getting the concept of the accumulator function in your mind. Now, we can pick a random function. Again, I'm using a polynomial simply because it's easiest to graph. And if you don't like the look of it, you can modify it and bring things down if you want. Let's see if I can change that. Let's maybe bring this down a little bit more. So the accumulator function here accumulates area. This integral represents the area from 1 to an x. And right now, when x is 1, the total accumulated area under this curve is 0. If I change the x position, you can see that the program is calculating these integrals on this polynomial that you can't even tell what it is, and is finding that right now that sliver of sort of blue-green is 1.478 according to the scale that we have there. It accumulates, keeps accumulating area. Once it gets to this point here, however, watch what happens. It's accumulated, it's all the way up to 18 something. We start accumulating some more. Look, it's going down. That's because when we accumulate area and we're moving left to right the way we read, areas above the x-axis are positive and areas below the x-axis are negative. I always tell the kids that, we sort of fib to you in geometry when we never said that you couldn't have negative area. We just said, you can't. We said, you can't have negative area, can you? We were asking you a question because we really knew that there are times when we consider there being negative area. And that's when the area is under the curve is negative and above is positive when you're going from left to right. Now, this gets really complicated, and the reason why I had to write this program, or felt like I had to write this program, is watch what happens here. When we accumulate area and we go from 1 to like 0, look, we're above the x-axis, but the area is negative. When you read backwards and you go from right to left instead of left to right, areas above the x-axis are negative and those below are positive. So watch when we start picking this up, the area gets positive again, and then now we're adding more negatives, and now we're going to add a bunch of positives. I hope you followed that. Let's pick another random function, and maybe we'd want to get something that has some things that we can have here. Now if we accumulate area from this line 1 and go to x, actually we can actually change, not always from 1. You can have things accumulate from 0 or wherever this red line is. I put initial point here. So if we accumulate area starting at 0 and we go to x and we go to the right, all of this area is negative because it's below the x-axis, and now positive going on. But if we go back to the 0 and start accumulating area going backwards, the area under the curve is positive area, and then the area above the x-axis is negative area. Kind of messes with your mind, doesn't it? Maybe you want to rewind this and go through this again, or go back on the movie. Now, the AP people are going to test to see if you understand what areas are positive and what areas are negative. And the way they do that is with problems like this. They'll present you with some sort of discrete function because they don't want you to be able to use an equation to get this. And we want to accumulate the area from -4 to -2. So we're going to, let's get a marker here. See, this is where we start, -4, And this a of -2 means that we're going to accumulate area to the -2. So right here. Well, if we're accumulating area here, and we're going from -4 to -2, that's the direction we read. Count this area. It's 1, 2, 3, 4. It's below the x-axis, so it's -4. We check. We win. Let's do a new problem. This time we're going to start at 0, and we're going to go to -8. 1, 2, 3, 4, 5, 6, 7, 8. So they want us to see from 0 to -8, 2, 3, 4, 5, 6, 7, 8. We want to accumulate area to here. Now the area is always between our function and the x-axis. So what they really want us to do is to get all this area and all this area and add them up and then put the answer in here. And if we're starting at 0 and we're going to -8, we're going backwards. So this area here would be negative, and this area here would be positive because we're reading backwards. And when you're going backwards, the area above the curve is negative and the area below the curve is positive. Does that make your brain into a pretzel? It could happen. I'm going to clear this and minimize this. And then I want to show you that I'm not completely sadistic. I did you a favor. I put show areas absolute value. I put some yellow lines that are hard to see here, but I put some numbers here. The area, you can calculate these areas from trapezoids, and you should make sure that you could calculate, because the AP people will not be giving you numbers like this. But I thought it's child abuse. I just really want to make sure you can tell the positives from the negative. So this area, 1, 2, 3, 4, 5, 6, 7, and then half each. This trapezoid right here has an area of 8. Its absolute value of its area is 8, and this one's 5, and this little bit right here is 1, and this is 5. So what we need to do is to think about, we're going this way. This is 8, and this is 5. So this area up here is 13. And since we're reading backwards and we're getting down here to 1, 2, 3, 4, 5, 6, 7, 8, and we're trying to go to this line. This is above the x-axis, we're reading backwards, that's -13. And then this part right here is 1, and this is 5, so this area over here is 6, but it's +6 because it's below the x-axis, and we're reading backwards. So the accumulated area is -7, which means the preponderance of it is here above the x-axis. So I'm going to minimize this and put in a -7 and check, and we win. Let's do another problem. We want to go from, it's 2 to -8. It's going backwards again. Let's do 6 to -8. -2 to 8. -2 to 8. This is 1, 2, 3, 4, 5, 6, 7, 8. So we'll bring the marker up. It's to here. So we want to know the area. Now this stuff we're reading from the purple line to the red line. That's the way we read. So this area would be negative, and this area would be positive. And so let's not be crazy. Let's use the helps that I gave you. For a few problems, you should not use the helps because you want to make sure that you could calculate those trapezoid areas for yourself. So this area down here is 8 plus 8 plus 5 is 21. And we're reading in the right direction. So that would be -21. And this part right here is 11. So it looks like our grand total of area would be -10. So I'll minimize that, put in -10. Check, we win. I hope that you can see how this program works. And if you keep making sure that you can get these right no matter where the starting point is, no matter what the accumulator function is, and can sort out positive and negatives, and teachers could even actually take screenshots of this and use these for tests, because these are a pain to make up problems like that. So this is the accumulator function, and we can go back and once again let's pick a random function, and if we start accumulating from 1, or maybe I will go down to 0. Oops. And we start accumulating area here, function area. This is going to be negative till it gets to this point, and then it's going to be positive and then negative again. If we go backwards, this little bit right here is going to be positive area, then we move into negative area, then back into positive area, accumulating, adding them all up. I hope this program helps you understand it. It surely helped me once I wrote it to see how the positive and negative areas played against each other. It helped me to, even though I understood it before, just visualizing it entrenches it. And I hope it does the same for you. Thanks. Bye.